Master Plan Part 3. So, as Zach was mentioning, the thing that I think is we wanted to convey, probably more importantly than anything else that we talk about here, is that there is a clear path to a sustainable energy Earth. It's not, it doesn't require destroying natural habitats. It doesn't require us to be austere and stop using electricity and sort of be in the cold or anything. The story, and I think this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans could actually be supported sustainably on Earth. And I'm just often shocked and surprised by how few people realize this. Most of the smart people I know actually don't see this clear path. They think that there's not a path to a sustainable energy future, or at least there's not one that is sustainable at our current population, or that would have to resort to extreme measures. None of this is true. So we're going to walk through the calculations for how to create a sustainable energy civilization. Yeah.
And to set the stage, today our energy economy, let's be honest, it's dirty and it's wasteful. Over 80% of global energy, primary energy, comes from fossil fuels, and only 1/3 of that global energy actually ends up delivering useful work or heat. This is the problem statement, but we're here to talk about the solution.
Yeah, it's like for some of this I'm going to elaborate because there's a very wide range of technical expertise out there, from people who are like, whatever, level 9 wizards in the subject, to people who do not do engineering at all. So, if you have a gasoline car, you're converting less than 1/3, often maybe only 25% of the energy in the gasoline is converted into motion. The rest is turned into waste heat. That doesn't do any good at all. And there's a lot of energy required even to get the oil out of the ground, to refine the oil, and to transport the gasoline to the gas station. So when you look at all that, for a typical gasoline car is actually going to be using less than 20%, fully considered, of the energy from the oil actually goes into motion. So this is when we see people doing calculations for what does it take to create a sustainable energy Earth, they assume that the same energy amount is required for an electrified civilization versus a combustion civilization. This is not true, because most of the energy of combustion is waste heat.
And even to get the fuel to combust in the first place and get it to the end use, there's a lot lost along the way. I mean, this is the primary energy consumption, 165 petawatt hours a year. Petawatt hour is a trillion kilowatt hours, so it's a large amount of energy. But the nice thing about an electrified economy, there's a better way, we're going to talk about it, is that through end-use efficiency and through efficiency along every step of the way, actually the total energy use halves. So this is one of the most enabling aspects of electrifying everything, is that the sustainable energy economy is that much easier to accomplish. It's actually half the problem statement of the fossil fuel economy.
Yeah, and we're being conservative here, so it could be better than half, but we're trying to have assumptions that are reasonable, not overly optimistic, in fact slightly pessimistic. So it's really better than half, but just say it's easy to make the argument that we need half as much energy with an electric economy versus a combustion economy.
Yep. So how the master plan works, you want to talk about?
So the thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. This is a lot of batteries, but it is actually a very achievable amount. We'll go into details on that.
Yep.
So that's a combination of electric vehicles and stationary storage. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. And so we're assuming sort of an 8-to-1 ratio of stored energy to power. So 30 terawatt hours of power, 30 terawatts of power. Our actual capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build this sustainable energy economy.
Yeah. Now, if you look at the total world economy, it's just under 100 trillion. So if this was spread out, say, over 10 years, it would be 1% of the global economy. Over 20 years, it would be 0.5%
Very
of
doable.
the global economy. So this is, not a big number relative to the global economy. As Drew mentioned, you need about half as much energy with an electric economy versus a combustion economy. And in terms of wind and solar, how much land would be used? It's less than 0.2% of the land area of Earth. Generally, people don't realize quite how much energy is reaching us from the sun. It's roughly a gigawatt per square kilometer. And the sun doesn't shine all the time, but it's if you multiply that by, say, 4 to get the continuous power, 4 or 5, then that gives you the land area of solar. And you can put wind and solar often in the same place. So a lot of places that currently have wind, you could have solar there and you double your energy.
You can also
output.
put wind offshore. It doesn't even need to
Yeah.
be on land, so wind is even more flexible.
You could put solar offshore too.
Yep.
So Earth is 70% water. Anyway, the point is that with a really a remarkably small amount of Earth's land area, we can go fully sustainable. Yeah.
And do the resources and raw materials exist to support this transition? We'll go through that in detail, but we do not see any insurmountable resource challenges at all. In fact, in the end, we should be mining less ore to accomplish this economy than we currently do with the fossil fuel economy, and we're going to talk through that.
Yeah, just to emphasize that again, the electrified economy will require less mining than the current economy does.
Yes.
Less, not more. Okay.
So this is the plan, and now we'll get into a little bit more of the details of the plan.